Okay, rational functions. So now we're going to be dealing with fractions and the variable parts of fractions. Okay, we did a little bit of this work in grade 11. Okay, so our number one rule in math fractions is what? Having a zero on the bottom. That's our big thing. We can't divide by zero. Okay, so you're going to see me writing this quite a bit on papers. An NPV is called a non-permissible value, something you don't want X to be. So the non-permissible value of the first one is X, a value of what don't I want it to be on the bottom there? 2. Okay, the next one. Do I see it right away? Some of you might see it. Some of you might say, ooh, maybe I should factor it. I could do that. What style of factoring is that one? All your styles? Greatest common factor, I can go 2 out, and then it makes an X subtract 5. So now the non-permissible value is the X value of, do you see it now? A 5, right? 5 subtract 5 is 0. Okay, I'm going to jump to these ones, and then I'm going to actually tackle that one last. Okay, this, what should we do with the bottom here? It's a factor. What style? Difference of squares? Okay, so 2 brackets, XX, and then when you do the difference of squares, plus minus 3. So what are the X values that are not permitted? There's actually 2 of them, -3 and a +3. Okay, the last one. Do you recognize the style? Simple, trinomial. What multiplies to 14? 7 times 2. Okay, so the non-permitted values for X are 7 and -2. So when we talk about domain, those are the values not in my domain, right? I have to skip over them. So for instance, a domain would go from -infinity to -3, skip over, and then I would go from -3 up to 3, skip over, and then I would go from 3 to infinity. So we kind of did a domain like that before, right? Okay, the last one is different. By the way, this is not a factor. You can't factor that. What would X squared, not X, what would X squared have to be? -1. Is that possible? Can you ever square something to make negative? No. So, there's no values that create a problem. Let's throw in some random numbers. -10. -10 squared is 100 plus 1. Good, right? Also, you can make some connections physically. If I was to ever graph X squared plus 1, do you understand that that's what it would look like? It's never, ever, ever, ever 0. Don't have a problem. Okay. So here, the non-permissible values will create asymptotes. That's what they're going to do to your graph. So we talked about the x can't be -3 or x can't be 3, so we create asymptotes there, and they're vertical. And when you draw vertical lines, it's x equals. Unless this happens. Unless there was a cancel, instead of making an asymptote, it's just going to make a hole in your graph. So you can see here, there's just a hole in my graph. Whatever my graph is doing, I'm going to put a hole there. I gotta have to figure this out. We're going to learn how to figure that out. Okay? And I'm drawing it kind of big so that we can hopefully see it. Okay, so that's half of the unit. Understanding that part. Now, the other half is understanding what's going on with the y's. So that was understanding what's going on with the x's. Okay. First of all, from the background experience you have, what degree is this equation? Oh, we haven't learned this polynomial function stuff yet. What's the degree? What's the highest exponent? 3. It's a third degree equation. Okay, the highest exponent I would see is 3. And the leading coefficient would be 2. Okay? Lots of you think, well, the leading is the start. Well, when you actually write this out, you should have started it differently. You should have thought about it. If I rearranged it, it should technically look like that. We always do the highest, and the leader is the one of the highest. Okay, you always got to look at the highest. Okay, so here's the rules. This is a second degree, and this is a first degree. Okay, ready to think about this? When you're in my advanced math, we do kind of a unit like this. What happens with numbers when the top number just gets bigger than the bottom number? What's going to go on as a general sense of your number? When the number on the top gets bigger than the number on the bottom, what happens to your number?
The number gets bigger.
Your number just gets bigger. So I'm going to say that there's no restrictions. Your number just gets bigger. Okay, let's jump to the bottom one then. So this is a first degree and this is a second degree. So what would happen to your number if the bottom number was going to be getting bigger than the top number?
It gets smaller.
Your number gets smaller. So I'm just going to give you an example. 1 over 10, and then 1 over 100, and then 1 over 1,000. What do we actually end up just getting closer and closer and closer to in a number when we get smaller, 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 smaller? We get towards
0.
0. Okay, we did that with reciprocals. We said if we are going to end up going closer to 0, that's an asymptote. Okay, and then this example, this is a first degree and this is a first degree. So they are changing at the same pace. Okay, obviously here, the top was at a faster pace than the bottom. Here, the bottom was at a faster pace than the top. These are changing at the same pace. So let's pretend I had 10 million divided by 5 million. They're both the same. What does that divide to? 2. Okay, and that's always going to be the number of when you just divide the leaders there. Okay, some of you might have asked, well, what happened to this 2? Okay, in the big sense, if you have 10 million and 5 million, does the value of 2 really make a difference? Not really. It's so irrelevant that it doesn't matter. Okay. It's like the x part's an ocean and 2 is adding a raindrop to an ocean. So it's kind of irrelevant at that point. Okay, so we have non-permissible values, can be asymptotes or wholes. We have degrees. We either are going to go no restrictions, a number restriction, or 0. Okay, let's see how we do it. Okay, I'm going to factor the bottom here. Okay, now, what are the x values that I don't ever want? I don't want a -5 and I don't want a -3. Okay, now, guess what? There's a cancel. So at -5, we're going to have a whole. And at -3, we're going to have a vertical asymptote. Okay, they make asymptotes unless they cancel, they're just wholes. Okay. I don't know if I read this or not. POD, you're probably like, where did that come from? The fancy name for a hole on a graph is a point of discontinuity. That's the name for it. It's a point that discontinues. It's a hole. Okay, let's talk about our second half. What's going on? The degrees. What's going on with the degrees? We have a first degree and a second degree. So it's higher on the bottom. We got more number on the bottom. So now what happens? Get closer to 0. Okay, so let's set some stuff up here. I'm going to draw my 2 asymptotes on there. That's all I can start with right now. Okay, so there's my asymptote, x equals -3 and y equals 0. Okay, your whole, don't worry about it yet, we got to get to there though. Okay, we canceled that off. So does this sound right if I do 1 over x plus 3? Is that okay with you? How I got that? I canceled that. Hello. Mm-hmm. Yep. Oh, that's right. Friday is a no school day. Yep. Okay. Sorry. Yes, that is right. Okay. Fine. Okay. So there's my simplified equation because I canceled. Okay. Now what I'm going to do to get a pattern is I'm going to pick a couple x values on the left. So I'm going to go -4, -5, and -6. And I'm going to pick a couple x values on the right. By that point, I'm going to see the pattern. Okay, so plugging in a -6. Here we go. -6 over -6 plus 3. And we can do this without a calculator. I believe in us. What is that number without a calculator? -6 over -3, 2. So -6 comma 2. Okay. -5. You can do that without a calculator as well. I believe in you. What is that? 2.5. Okay, did we remember something though? It's a whole. So at -5 comma 2.5, I'm going to kind of draw it. I don't need to draw it that big, but I want to make sure you can see it. That's a hole in the graph. Okay, -4 plugged in makes -4 over -1, which makes 4. Okay, do you see what's going on? Your shapes are always going to form around your asymptotes. So remember how to draw with asymptotes. You go closer and closer and closer to them. Okay, let's jump to the other side. Obviously -3 doesn't even work. Okay, so -2 plugged in. You guys, what was I doing? Why didn't anybody stop me? Why did I put a -6 on the top? -5 on the top? Why didn't anybody stop me? I just did that whole thing wrong.
I just assumed you knew better.
No, I don't know
I
better.
don't know why we're doing that.
I don't know better. It's going to be completely wrong. No one stopped me. Was anybody questioning me in their
I
head?
was a little confused.
Wow.
Why it was, well,
Now we know you guys really trust what I'm doing, apparently, because that was wrong. I'm sorry. Wow. Completely butchered that one. Like, where did the -6 come from? Well, they made really nice numbers. That was kind of good.
Yeah,
I'm sorry.
at first I was confused and then the numbers came up and I was like, well, I guess.
I know, those numbers did come out nicely. 1 over, 1 over, 1 over. I'm not sure why I did that. Okay. Yeah, now if we all this test is just all my fault. I'm recording this too. I'm sorry. Whoever's gonna watch this, Gavin. No, you're not gonna watch it. Faith, I'm sorry, Faith. I wish I could just rewind this video. Okay. Okay, well that's just -1/3. So that's not as fun to graph, but so that would be the point. -5, -1/2. Don't forget, it's still a whole. And -4, comma, -1.
That's significantly less nice.
Okay,
Let me go back to the other numbers.
there's the new points and the asymptotic behavior. Okay, let's do this second half correctly the first time. I'm just going to write this right now, 1 over. Okay, getting your values, so this makes a 1 over 1. This makes a 1 over 2, and this makes a 1 over 3. Okay, -2, comma 1. Okay, there's your 3 points. Connect them. Draw some curving at your asymptotes. Okay, number 2. Let's see if we can do 3 today. I'm not going to do them all. There's a bunch. Okay, the first thing is, what kind of x value do I not like? -1. Do you think that would cancel with anything on the top? No. Even if I could factor that x plus 2, x minus 2, but there's no cancel. So it is a vertical asymptote at -1. Okay, let's talk about the degrees. What's going on? It's higher on the top, right? There's a second degree on the top and a first degree on the bottom. It's higher on the top. What happens in math when your top number is higher? You're just getting bigger. Okay, that's it. That's all we have to work with. So when I'm starting out, I know I drew this table for you. You're not going to have that table. You're going to want to pick 2 to 3 points on that side, 2 to 3 points on that side. I mean, pick 2 if you see the pattern, that's fine. So you can see I'm picking that side, and then I'm picking some on that side. Okay. -4 squared minus 4. So that's what I'm mathematically doing each time. So this is 16 subtract 4, 12. This is -3, making -4. Are you okay if I just want to cheat on the rest? And just let my calculator do it? No, like I'm like super cheating, not like a little bit. You ready? -2.5. Are you okay if I do this? Do you see how I'm just going to get those numbers? It just takes a long time. 0. Obviously, -1 was an error because that's our asymptote. At 0, -4, -1.5, and back to 0. Okay, graph those points. They should make shapes that go around your asymptotes. Actually, just our one asymptote, right? That will just start curving down, 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 and it would go on forever because there was just no y restriction. So just going up and down.
Oh, I did it. Good job. Great.
Okay, and again, there's no restriction in our range part of it. Okay, one more. Okay, non-permissible value. 1 is the x value on our domain that we're worried about. Is there anything that would cancel that off? Nope. So asymptote Okay, so we know that. Now let's talk about the degrees. What do we see here? It's the same. So that's what we have going on. We have the same rule. So what do we do when the degrees are the same? We're going to divide 5x by 1x, making a 5. Okay, so there's our horizontal asymptote. Okay, so let's plug in. When I pick values, I'm going to be going with a 0, a -1, a -2 on that side, and then I'm going to pick 2, 3, 4 on that side. So that's why I have those numbers there. Okay, so 5 times -2 over -2 subtract 1. makes -10 over -3, which is, it goes in there 3 times and then a third, 3.33. And are you okay if we just cheat on the rest? Okay. There's your cheating values. -1 is 2.500. Okay, error. We hit our asymptote. And then I had 10, 7.5, and 6.67. Okay, you can see I have plotted those 6 points, and then when you connect them, just make sure they're kind of curving and they go towards your asymptotes. So sometimes when you're graphing these and you find that your points make you cross over an asymptote, you did something wrong, okay? And then we talked about an asymptote drawing. Don't ever do this, okay? You never draw going away from an asymptote, okay? Okay, so if I see something like that, I would give you one of those small point reductions because you just kind of communicated something wrong.